for your patience. We're going to talk about Earth Engine. Does everybody know what Earth Engine like is? Okay, sort of. Cool. So there's a ton of better tutorials out there than the one that I'm about to give. So just be aware of that. And there's like all kinds of really great resources. The stuff that I say today is definitely not like comprehensive. So here's what the people said. I'm a man of the people. So here's what the people said that they wanted. And I'll cover this, but also touch on some of the other things. But if you need to do whatever, just like let me know and we can talk about it. And then I'm gonna do definitely these two and some of these, but probably not Grace today. It's a bit more complicated.
Also, quick question. I thought Sentinel-2 was optical.
Then maybe I mean Sentinel-1.
Okay.
Yeah, whichever is not optical. The star.
It could be Sentinel-3 as well.
Yeah, beats me. You're the guy. You're the star guy. Okay, so motivation. All right, so let's say this is a question for the room. Let's say you wanted to calculate the mean something, NDVI or like some Landsat band for 15 years of data for the entire Central Valley. Like, how would you do it before Earth Engine? This is how I would do it, right? People would maybe do it differently. This could take like hours to run and like hours to write, frankly, depending on the data and how it's stored. But in Earth Engine, this is pretty much like 2 lines of code and 10 seconds of processing. So it's a really powerful tool, which allows you to leverage like Google's cloud, as opposed to like running routines on your own computer. So it's a lot faster and more flexible. So how it works, and there's like a few key concepts that underlie like how you work with the data and the way that the computations take place. So the first thing is like the difference between the client and the server side. So the procedure that I just described to calculate the mean something over the Central Valley for 15 years, where you download all the images and process them on your machine, that would be on the client side. The server side means everything is done remotely, like in the cloud. So Earth Engine is completely done in the server side. So what happens is basically you write a routine and then submit it to Google, and they do all the processing and just return you the results. And so the other thing is like deferred execution. So no expression actually gets like evaluated unless you need that value for a subsequent computation, which is great because if you have like unused bits of code that don't get used later in your script and nothing happens to them, they don't even run. So, and then the last thing that this is like kind of a get you sometimes, like the image pyramiding framework that Earth Engine adopts makes it so that the spatial resolution is automatically computed depending on the size of your area of interest. And basically like it will return the same-ish results. And you can just specify like the nominal scale of whatever data set to make sure you're getting the total results. But if you don't specify anything, it will calculate like its own scale according to this like pyramiding type geometry here and the size of the image. Because they don't want to compute like too much in parallel. They have like a load for each user. So definitely was a bit confusing for me, especially at first, because the way that this is set up is not like Python or like MATLAB. It's more like asynchronous. It's like JavaScript-like. And so instead of for loops, you do what's called mapping and reducing. So you kind of map a function over an object rather than like writing a for loop to loop through an iterable and applying a function like that. So it's a bit confusing, but like once you get the hang of it, it gets pretty seamless. And there's so many examples out there that you can pretty much just like copy paste, copy pasta, like whatever you need. Okay, so starting super basic, like so the data model, like they have a few different like terminology for things that we're all already familiar with. So image is image, like it's a raster, it has pixels, right? It's 2D, so just a 2D image. A feature is a vector, it's like a shapefile or like a KML or whatever, something with the geometry and like multiple points and a column of, or many columns of attributes, right? And then you have the image collections, which is like a 3D stack of the 2D raster images, and a feature collection, which is like a set of polygons or like a multi-polygon or a set of shapefiles or whatever. So these are kind of the fundamental data types. And basically, like that's most of what you will work with if you're working with this. Now on the map reduce, so the like a reducer, which is a key concept in Earth Engine, is basically just a way of summarizing statistics through a dimension. Okay, so you can summarize through the spatial dimensions or the temporal dimension. So for this instance here, you're taking some kind of summary on a per pixel wise basis through time, right? Through this like stack of images. So you could take like the mean or the sum or the standard deviation or the max or like whatever you want, or other kinds of thresholds. You know, you could set a condition based on one image and then apply that to the stack, like all kinds of things like that. Is this kind of making sense? Like, okay, cool. It would be like NP, like take the mean access equals 2 in like Python or MATLAB, right? Or maybe it's a different access in MATLAB.
Yeah, you would do like mean the stack, comma 2.
Right. Okay. Yeah, I'm not a MATLAb. In Python, it would be access equals 2. That's less verbose. Okay, cool. So like I said, I'm gonna like demo everything, and this has like lots of scripts and stuff that you can like use to get started. So there's 29 petabytes of data on Earth Engine, which is just an obscene amount. And I mean, there are like, you can look at the scroll bar, like there is all kinds of stuff. So does anybody want to just like throw out a variable, like a climate variable or like a hydrologic variable, like anything? First thing that comes to mind. Wind speed. All right, out of all of those, this is the one that has this exact match. But so the way that I would browse is like I would search for a variable like that, see what comes up, and you can click into it. You can see it's got, here's like the description. It's got these various bands associated with the data set. And then this is actually really helpful. It has like the canonical reference. So if you really need to dig in and figure out like, oh, how does this product work? How did the algorithms to like do this get designed? You can go and check it out here. And then DOI is same. And then this, it has like a pretty handy little clicky where you can just go. All right, sweet. Worked. So you can see it's popped open this screen now. And this is called the code editor. And I'll talk more about this in a bit, but I'm just gonna click this button, run. And what it does is it shows the wind speed data. And so that just happens if you click this little thing right here. So there's also like all of these different tags. So you can search by like, for instance, like here's evaporation, you can click it. Here's all the different data sets they have with a band or a layer of evaporation. And there's like, you know, tons of these. There's also these data sets that people, you know, publish on or like create, and they can submit them. And then Google will actually like upload them and put them in the catalog. And that's part of the reason that there's so many, because people are making this stuff, they're submitting it to Earth Engine, and they're just uploading it. And there's all these like cool tools that I haven't even really dug into yet, but like they can even let you optimize your search further. So here's like a nice little Medium post on some of that stuff. Any like questions or anything so far? Or we're at cruising altitude? Okay, so this is the code editor thing that I showed. It's like a little coding platform plus a map visualizer in one. And So, here is where you would write the code to like render the images, do the displays, do whatever processing you want. This pane right here on the left, like there's docs for all of the different algorithms that you can search. So, I mean, you can do like classification and regression trees. You can do like machine learning stuff in here. And those, I don't usually do that, but you can. Then there's also this tab here, it's kind of hard to see, called assets. And those are like all the scripts that you have. So I have like dozens of scripts here in Earth Engine, and you can just save them right here. And if you go to that tab, in fact, why don't I just go to mine? Oh, well, sorry, it's scripts. Can you see this? It's like showing all of these different scripts that I've made like over the years. And if I just like click one, it'll pull it up. And you can save them. And if I click this get link button, then you can easily share this link with anybody. And whatever I'm seeing on the screen here will be exactly what they see. So there's a bunch of these links in this tutorial actually that you can just click on and do exactly what we're doing. What else here? Oh yeah, so then this window on the right, it kind of is like your outputs window. So if you make any like plots or charts, or if you print something, or if you want to print some information about the images or the stack of images, it will get displayed here. Yeah, and there's like a bunch of other stuff, like there's these geometry tools so you can draw shapes and edit shapes and click them on and off and whatnot. So anyway, that's kind of boring. So I'll just like show an example here. Okay, so I'm just gonna, I just clicked this link and I'm gonna click run. And so what's happening is it's just fetching all of these different data layers for, if I zoom out a little bit, you'll see this is like in the Southern Central Valley. Then the data will load a little slower. Oh, it's going pretty fast actually. And so you can see, so I've given this little geometry box right here, and we're going to calculate some statistics and charts and show you how to download data and show all the different like layers and data sets that like I commonly work with. So if you just look at the GUI right here, there's this layers tab. And this is like showing all of these, different data sets that I've loaded. And so, we talked about the concept of reducer. So what I've done is actually for each image, it's just showing the median pixel value between 2014 and 2019. So I've reduced the dimensions of that time stack, that 3D stack, into 2 dimensions, and that's what it's showing here. And it's showing it for lots of these different data sets. Oh man, now I zoomed in and it's like, got to do it all over again. But that's okay. So yeah, maybe I'll like, I don't know. So
is it just re-rendering that every time you zoom in, or is
yeah,
it actually rerunning your script?
It's just re-rendering.
Okay.
And it's actually pretty smart with the caches and stuff with those pyramid levels. So if you load something at one pyramid level and then zoom back to it, it will be fast.
Okay.
Yeah. I should have like ran this and like rendered it beforehand, but I think you kind of get the idea. Like all of these different things, and the layers are, they're pretty nice and like clicky. Oh, somehow these come all like twice, but yeah. So for instance, like this is Sentinel, not radar. This is the National Agricultural Imagery Project. This is precipitation, Landsat, this ecosystem type layer from the USGS, crop type from the Department of Agriculture, slope, and elevation. And all of these have visualizations that you can like play with. So let's play with this elevation one a little bit. You can click this little like, this gear thing. And if I want to change the range of values, like let's stretch it like 1 standard deviation and hit apply. And you can see like the color map changed. So if you want to show just like quick and dirty visualizations of some data sets, like this is a pretty easy go-to thing. You just like screenshot it, mess with the visualization a little bit. You don't have to download anything, and you're done. So yeah, and yeah, like okay. And then you might have noticed this little pane right here. And so if you recall this geometry that I put up before and some of these layers, what this is doing, and let me just pop this out, it's bigger. What this is doing is just showing like the percent area in square meters for each of these different, these are ecosystem types. I guess let's do the crops. They're probably more interesting to us. So these are all the different crop types, sorted by area and square meters over that area. And you can they have the interactive plots and whatnot. So Fraz is asking a question. How did you import the geometry? Also, did you create the geometry in GEE or import it into GEE? So good question. The geometry is like pretty easy. You can just clicky like one of these buttons. So, okay, I did just define it right here. I just supplied the lat longs, but let's just take that out and let's draw a different polygon for fun, just to give you a feel for how it works. So I'm just gonna make this one small so it loads quicker. So this is probably Tulare somewhere. So let's get rid of this guy, and we can make this. And you can draw whatever freeform shape. So I just made some random thingy. It gets automatically put up here into your imports. And if you want to look at the coordinates, you can just click this and there they are. But it's already called geometry, so we should be good. So if I hit run, everything automatically happens again. The map centers on the geometry that I just made, and we make the same plots just for that area of interest. Does that answer your question, Sarfraz?
Yes.
Sweet. Okay, so yeah, I don't know, this is kind of nice, and you can download these as CSVs, as images, or you can just screenshot them or whatever too. So reasonable for making charts and plots. And you can do time series. So this is the NDVI over time from Landsat. Same thing, you can download the CSV or the PNG, but perhaps more, yeah, I mean, there's lots of different types of plots. So here's a bar plot of precipitation. I think this is chirps that I use. And then I want to just highlight that there's everything from daily data to monthly to annual to long-term averages. So, you can visualize the monthly data too and download it or as a data or the image. Gonna mention something, but forgot. So anyway, that's kind of the reducing example and making plots and charts over an area example. And I should mention the reducers that I was using was basically mean for everything, but you can think about doing the standard deviation or the min or the max, depending on what you're interested in or what problem you're trying to solve. So I'll pause quickly. I don't think I have an hour of material here.
So say you want to plot two precipitation in the same chart. How do you do that? Two same data in the same
Yeah,
time
good
series?
question. I suspect it would require messing around with one of these functions. You might just be able to what you could do is create a feature collection from them and then pass it through this function, or perhaps specify different image collections. I'm actually not super sure, but I can guarantee you there's an example for that in the documentation.
But it is doable. That's
It's definitely doable. Wes had a question.
Yeah, I was just back on the geometry thing. I'm assuming it's pretty simple to just upload a shapefile, then you can go over that region as well.
Yeah. So yeah, I should have mentioned there's this class here called assets, and you can just upload like a KML or a shapefile or whatever. You literally just drag and drop it into there, and it will get automatically uploaded into your project, and then you can run all these scripts against it too. So moving right along. I thought I would just include this one. I think we show this in the water course, but and this kind of is starting to talk about what Surprise is interested in, but let's say we want to show different statistics for multiple polygons. So I've now split out, I've taken the evapotranspiration data for the Central Valley, and I've just masked the counties that fall fully within, I think they're just the counties that the people in the water course did last time. And so I have masked the ET, the mean annual ET by the counties. And then here we can plot, per county what the mean annual ET is. So it's a pretty quick way to then just like do these categorical multi-polygon analyses things. And certainly, this is like 80 lines of code. So probably quicker than downloading and, doing the summary stats on your client side machine. But of course, like you might want to download something, to put it in GIS or whatever. So here's a little example of downloading some elevation data, and I just defined this polygon the same way. And if you see, and you just add this little snippet of code right here, which is export to Google Drive. It's pretty simple, and you can specify the scale, which is basically the spatial resolution that you want it to be aggregated to. And then if you see right here, this tasks window has lit up in orange. So if you go there, it wants you to run this. And if I click run and run, it will just go ahead and download this as a GeoTIFF to my Google Drive. So it takes like a few minutes. And if you're doing like a big operation, like it can take like many minutes. But I have a nifty way around that I'll share with you later.
I have another quick question.
Yeah.
Say we have our own data set that we want to put in there to compare with other available things in the catalog. Is it pretty easy to do it locally, or do you have to like submit it to Earth Engine and then it becomes public?
Yeah. I think that there's probably a good way to just upload like a GeoTIFF and keep it private. In fact, I know that there's a way because some of the NASA people working on OpenET like shared with me some like private assets that they've uploaded, I guess. But I don't actually know exactly how to do that. But I'm sure there's like some docs or something that makes it pretty simple. So one of the things about Earth Engine that really confused the hell out of me like at first was if you try to do, and this makes total sense, like if you try to do too large of a computation, like it will say no, right? So if you want to take the 30-meter mean for daily, or sorry, let's say you have daily 250-meter MODIS data for the whole United States, and you want to take the mean for each pixel for the last 20 years, it'll be like, no, like that's going to take a year, that's going to take like way too much compute from Google, and we can't do that for you. So it will actually kick you an error. I should have wrote something that would error on purpose so I could show you, but the error is basically user memory limit exceeded. But a workaround for that I've developed after much frustration is breaking whatever shape you specify into a sequence of smaller shapes, and then doing the analysis at the scale of the smaller shapes, and then stitching it all back together. So here I'm showing an example of the Central Valley. And what you do is and I've defined it in this very long string of coordinates here. And then you can specify an X cell size and a Y cell size. And then this friendly European gentleman, Janadini Donkites, wrote a code that just allows you to generate a grid from whatever file given an X and a Y. So this is like another cool thing about Earth Engines, like you can like source other people's code and like packages and stuff. And so this has been really useful. And this was in fact how I was able to process some of the ET data for the Central Valley because it was very high resolution and lots of time steps.
Do you have any issues with like the boundaries?
As long as they're square, I've been okay. But what I do,
Like if you're taking a view of something and the resolution is different than the grid resolution.
yeah,
Is there-
Or am I getting like edge effects?
I haven't found any edge effects or anomalies with this. It's been reasonable so far. But the second, so what you can do is kind of like you could do this like, so instead of just showing the grid itself, what you could think about doing is intersecting the grid with the original shapefile. But as soon as you do that, like all of these weird like edge effects and like artifacts can happen. For instance, like here, you've got these like really spiky, you know, half things. And so I would recommend just using a grid cell size, like small enough to capture the shape that you want. So for instance, if we make this like, so that's 2.5, let's make it like 0.125. So like half the size. Then you'll see it does like a bit of a better job not overshooting the area so much. Feel me? Cool. So yeah, like I said, like this is just some of the stuff that I've done over the years, but there's way more on like these resources particular. So we covered this stuff. Okay, and then yeah, definitely don't have an hour of material today. So I did want to include, so the GUI and the graphical map and stuff are all like, they're pretty cool, but how I really like to work with Earth Engine, sweet, glad this is working so well. Oh man, why? Let's just switch windows again. So let's pray for me that this works. I have to share the whole screen. All right. You all see that? Yeah. So Earth Engine has this very cool Python bindings, which you can basically run all of the same stuff in the code editor online and just get it and like do the same operations in Python. And this is super awesome for me because instead of futzing around with like downloading CSVs or anything, like I can just read them right into like pandas or whatever Python package I want to do. So here are like some of the super basic Python libraries. And then I've also developed this like custom module to work with the objects that Earth Engine returns to make it like dead simple and super easy. So let me just show you. So just importing some libraries. Anytime you see RS, it's this like little wrapper that it's essentially like a wrapper around the Earth Engine Python stuff that I've kind of developed. And so I'm loading all of these different data sets that I've like just put into a lookup table basically. And so here are some of them, right? Like Landsat 8, there's the spatial resolution, there's the name of the variable, This is the Earth Engine function that you pass to the Python API that returns that object. And then there's just some like other information. So how do we like access some data over an area using the Python API? So another package is like for shapefiles and vectors is like GeoPandas, which I use a lot, and super easy to install and plot stuff. So here's the Central Valley. There's this function which converts GeoPandas object into an Earth Engine object, which is called area. And then I can just like define a start and an end time. And I'm gonna just basically retrieve Prism data over this area between these times with this function called getIms. And so you can see I just did like 1 year, 2019. These data are monthly, so there should be 12 images, and it didn't complain. So we can basically just like stack them in time and plot the mean. So that's like the mean precipitation, for each grid cell between 2019 January and 2019 December. We can plot the time series if we take the sum for each, time dimension. And if we want to write this to a TIFF, got another handy function called write raster. You just give the array, the geographic coordinates, and then the path to your TIFF. And like, let's confirm that did indeed work. So I'm in junkyard, Python. Okay, cool. And here we are. So like I said, like pretty simple for downloading stuff, processing stuff, just like getting it in a format that you can then do analysis on. And honestly, like that's kind of most of, oh, now we're back here, but that's most of what I have. Oh, I guess we can talk about these a little bit, but like once you have like a working algorithm or a cool map that you want to show, it's pretty easy to just turn it into a web app. So here's actually probably the coolest one. These people, this is that same European guy, Genadini Donkites, and he developed a way to look at the changes in surface water over time. And so you can see like there are these layers here that you can turn on and off. Here is like the changes. So an increase is shown in green. So you can see according to whatever algorithm, if there's surface water on this mountain, which is not true, probably. But anyway, like there's all kinds of like cool apps that people have made. Probably the most like famous one is this Global Forest Watch one, which is mapping like deforestation over time. And this is like that email that Rosemary sent a few weeks ago with the Earth Genome Project. The founder did this before he started that. And then the one that you guys have probably heard about more recently is OpenET, which uses Earth Engine to access all of its Landsat and optical data to then do the ET algorithm. So here's like that if you haven't looked at it yet. And it's uses Earth Engine under the hood. So yeah, that's pretty much it. And yeah, like here's the resources and everything, all the links that I showed are in the slide deck if you want to poke around or if you ever need to download or visualize something.
Is that Python package road, is that available on Git?
Yeah, it's in the envgp Git repo.
And then is that installable with pip or is that installed?
It's just a .py file. So if you just download the .py file and import it, it's pretty untested. So if you like use at your own risk, I would love for people to use it, but like, I'm sure there's small problems. So use with caution, but feel free to use it. All right, so Fraz is leaving, so I guess we can wrap.